Okay, so we're told in this question, when Katrin shoots an arrow at a target, she hits it with a probability of 0.4. When Rhiannon shoots an arrow at the target, she hits it with a probability of 0.3. We're told that successive shots are independent. Now this is a really important part, so I'm just going to underline that quickly. One morning they decide to shoot arrows alternately at the target, starting with Rhiannon. So the winner is the first to hit the target. Now the fact that we know that these events are independent means we can use the rule probability of A intersect B, or probability that A and B happens, is a probability of A times a probability of B. And this whole question relies on you remembering this and being able to use this. So the probability then for part A that Katrin wins on her first shot is calculated by looking at what must happen. First of all, Rhiannon must miss, so we need to do the probability that R misses. And then second of all, Katrin must hit, so it must be a miss and a hit, so we're going to multiply. So the probability that we have C hits. And so when we work that out, probability that Rhiannon misses is 1 minus 0.3, which is 0.7, times by the probability that Katrin hits. So the probability Katrin hits is 0.4, so this gives us an answer of 0.28. How do we get our marks on this question? Well, you can have a method mark for actually writing out this statement here, that you calculate the probability of this occurring with the probability of Rhiannon missing multiplied by the probability of Katrin hitting, and then you get an accuracy mark for actually carrying out that multiplication correctly. Okay, so let's have a look at part B. Part B says, show that the probability Katrin wins with her second shot can be written in the form K times 0.28 and state the value of K. So, probability that Katrin wins second. Now I'm just going to abbreviate my notation a little bit so that we can fit things in. What must happen here is we've got to have the probability that Rhiannon misses multiplied by the probability that Katrin misses. Then of course Rhiannon's got to miss again, so probability that Rhiannon misses times by the probability that then Katrin hits. So what we end up with here is probability of Rhiannon missing, we know, is 0.7. Probability of Katrin missing is 0.6 times by probability of Rhiannon missing again, which is 0.7, times by probability of Katrin hitting, which is 0.4. Now we have to pay attention to the question again here. It wants us to show that this probability can be written in the form of some constant k multiplied by 0.28. Now what I know is 0.7 times 0.4 is 0.28, so I'm just going to multiply these two together. So I get 0.42 times 0.28. So therefore k equals 0.42. Okay, so let's have a look at how we get the marks on this question. First of all, we get a method mark if you've correctly written out this long multiplication sum here, product of the four probabilities. Then we can have the accuracy mark for stating this line here, actually calculating that it's 0.42 times 0.28. Okay, now that might seem a little bit of an unusual question, but what the question is doing is actually it's building you up for part C. And we can tell that because it says hence. This word here means that we want to use the answer that we've had previously to help us with this question. Now it says, hence by summing an infinite geometric series find the probability that Katrin wins. Well, the probability that Katrin wins is found by doing the probability that Katrin wins, let's do on her first, so we'll do C1, plus the probability that Katrin could win on her second turn, plus the probability that Katrin could win on her third term, plus, and we can go on infinitely. What's actually happening here is as the amount of turns that Katrin takes goes on, the probability of it happening that much later decreases, because of course we're multiplying by these probabilities which are less than 1. But this could go on infinitely. They could ultimately end up taking an infinite amount of shots and never ever hitting the target. Now, we're just going to have a look to see how we can see this as a geometric series. We already know what the probability of Katrin winning on the first shot is, and Katrin winning on the second shot. Let's quickly look at Katrin winning on the third shot. So, and this will really highlight what's happening here. So probability of Katrin winning on the third shot is very similar to this. So we know that we're going to have Rhiannon miss, so 0.7, times Katrin miss, so times 0.6, times Rhiannon miss, 0.7. This time times Katrin miss, so this is where they've now both had second shots, multiplied by then Rhiannon missing again, this times by this time Katrin hitting. Okay, now what we want to focus on is these little blocks here. Okay, notice these blocks are 0.7 times 0.6 are repeating. So, I mean, it didn't occur in our first one when Katrin won on our first time, but when Katrin won on our second shot, we had one block, and when Katrin won on our third shot, we had 2 blocks of these. So we're just looking at these little blocks, and what you'll see is we then write this as 0.42 times by 0.42 times by 0.28. And if we think about this a little bit neater, what we actually have is 0.42 squared times 0.28. So, let's just roll down a second to give us a little bit of space. When we consider the probability of Katrin winning again, and actually put these probabilities in, so probability C wins, the probability of Katrin winning on her first shot was 0.28, plus the probability of Katrin winning on her second shot is 0.42 times 0.28. The probability of Katrin winning on her third shot was 0.42 squared, 0.42 squared times 0.28. And actually, the probability of Katrin winning on her fourth shot will be 0.42 cubed, because we'd have 3 blocks of these 0.7 times 0.6, where Katrin and Rhiannon miss 3 times. And this, hopefully you can see, now forms the geometric series that we're talking about in part C. It says an infinite geometric series. The reason for this is because we've got A, our first term, is equal to 0.28, and then we've got R, our common ratio. Well, to get from here to here, I'm multiplying by 0.42. To get from here to here, I'm multiplying by 0.42. Our common ratio is 0.42. So it's an infinite geometric series because the ratio lies in between -1 and 1. So my sum to infinity in that case, so the probability that Katrin wins, is actually, let's put it up here, the sum to infinity of this series. So, probability Katrin wins, let's just cross this out a second. If we work out the sum to infinity, we use A equals 1 minus R. So the sum to infinity equals A, which is 0.28, over 1 minus R, which is 0.42. Okay, now when we work this through and put this on our calculator, what we get is the fraction 14 over 29. So then the probability that Katrin wins is the sum of that infinite series, which is 14 over 29. Okay, so let's have a look to see how you obtain marks in this question? Well, method mark is given if you can identify, and actually you only really need to identify the fact that in this series it's going to be these first two terms, because really from that you've been told it's an infinite geometric series. You could take A as being 0.28 and then the common ratio of 0.42 as granted because it states so in the question. This was included just to really explain this solution to you, so hopefully you can understand it better. So your method mark is then obviously for showing this geometric series, so that you can take out that A is equal to 0.28 and R is equal to 0.42. You can then have an accuracy mark for correctly substituting that in to the sum of an infinite series formula. And then finally we can have an accuracy mark for calculating that probability is 14/29, or a correctly rounded decimal, but preferably that fraction. I hope that all made sense and that you understood it.